Okay, here are some examples of rational expressions and multiplying them. And remember, any value of the variable that will make the denominator of a fraction 0 is not allowed. So those are restrictions of the domain. I'm not going to write these all down because we did that in the simplifying problems, but those are all restrictions, and if you are asked to write the restrictions, then that's what you would put. Any value of the variable that makes the denominator 0 would not be allowed. So in this case, x cannot be 0 and y cannot be 0. All right, so let's just take a look at this now. Again, just like in simplifying, this is kind of like simplifying, but just any top with any bottom. If they're the same, they make a 1, and they kind of, what we say, cancel out. So when we see these, sometimes it's a little bit easier to expand them so you don't get confused, because you're saying there's 2 of these in here and 4 of those in there, so 2 will cancel with 2. So the safest way is just to write it out. So this is x squared is x times y. So I got x, y, and on the bottom I've got 4, which is 2 times 2, xy. So I just factor everything out. Over here I've got x on the top, and on the bottom I've got 6, which is the same thing as 3 times 2. And over here I've got 3, and I've got 5 y's all over 4 x's. X times x times x times x. So then it's a little bit easier to see what's going to make 1s or what we're going to cancel out. So I got 2 x's on the top here, so those will make 1 with those 2 x's or cancel. I got 1 more x on the top here, so that will take out another x on the bottom. I also got an x there. And I've got 1 y here, that will make 1 with that y. And I've got, I think that's about it. I don't have any more y's on the bottom, do I? And I've got a 3 here, that will make a 1 with that 3. And I think that's okay. I don't see any more y's on the bottom that I haven't canceled out. I don't see any x's on the top. I don't see any other numbers, so I'm all done. So what's left up on the top? 1, 2, 3, 4, 5, so y to the 5th. No numbers, and in the bottom, 2 times 2 times 2 is 8. And I have an x and an x, which is x squared. So there's your answer. 2 times 2 is 4, times 2 is 8, x times x. Okay? Number 6, well, kind of like when we were simplifying, we just factor everything. Now this is the difference of perfect squares, so this is going to be, and my square roots are x and 4. So this is going to be x plus 4 times x minus 4. And over here we have a simple trinomial or a trinomial square, either case. This tells me the signs are the same. They're both negative. 4 and 4, 2 and 2. 2 times 2 is 4. And then negative 2x and negative 2x is negative 4x. The top is already simplified. There's not much I can do with x minus 2. And over here I've got another simple trinomial. And I've got x, and numbers that multiply to give 8 and differ by 6. How about 4 times 2? Oh, I'm sorry, they added to be 6, excuse me, because the signs, this tells me the signs are the same, they're both positive. I should analyze my signs first, excuse me. And numbers that multiply to give 8 and added to be 6, 4, and 2. And now we just want to simplify. Any top with any bottom that are common will make a 1. So x plus 4 over, there's an x plus 4 on the bottom. Is there an x minus 4 on the bottom? No. Is there an x minus 2 on the bottom? Yes. And that's it. I don't have any more x minus 4s on the bottom. So up on the top I have, so this will be my answer, x minus 4 on the top. And on the bottom I've got these two, x plus 2 times x minus 2, x plus 2, x minus 2. And that's what you've got. Okay? Now again, if we looked at restrictions on our domain, anything that makes the bottom 0, so x cannot equal 2, negative 2, or negative 4, because any of those numbers will make the denominator 0. All right? And one more of these multiplication. And again, we've got, looks like we've got simple trinomials all over the place. And we use a little dot to represent multiplication. If we put an x there, sometimes we'll confuse it with this x, so we use a dot usually for that. And we got simple trinomials or difference of perfect squares. So we're going to have all these things are going to factor to be products of binomials. And this is going to be the difference of perfect squares. And these are all going to have x's here, because x times x is x squared. And here we have, let's take a look at the first one. This tells me the signs are the same, they're both positive, so x plus 1, positive, multiply, give 1, it's got to be 1. It's actually a trinomial square. Over here, this tells me the signs are going to be different, so large is negative, so negative, positive. Oh, this is 18. Sorry, I miswrote this. I was going to say that I can't factor that. I miswrote that down. That should be 18. Excuse me. That's why I got my white out here. So I say, wait a minute, I can't factor that. And I looked at my examples. These are coming off of a example sheet, so that should be negative 18. You don't necessarily have to be able to factor, but these I set up so you can't do that, can factor. So multiply to give 3, and, multiply to give 18 differ by 3, so that'd be 6 and 3, excuse me. And you always check these. Negative 6x plus 3x is negative 3x, but negative 6 times positive 3 is negative 18. So that's okay. Over here, this tells me the signs here are going to be the same. They're both going to be negative. Multiply to give 6, add it to be 7, so that'd be 6 and 1. Negative 6x and negative 1x, remember outside, inside, negative 1, negative 6 is negative 7. And last term, negative 6 times negative 1 is positive 6. And this is the difference of perfect squares, x plus 1, x minus 1. All right, so now we have everything all factored. So any common top with any common bottom. So we got an x plus 1 here and here. Any more x plus 1s in the bottom? No. Any x minus 6s in the bottom? Yes, there's an x minus 6 over here. And any x minus 1s in the bottom? Yeah, there's an x minus 1 here and here. So. And there we go. So what's left? Right over here, and we have an x plus 1 on the top. And we have an x plus 3 in the bottom. And we don't need parentheses anymore because we just have 2 terms in each. Now the restrictions on the domain, anything that makes the denominator 0. So I have a little room here, so I'll write this down, but we didn't write them on all of them. But we could say that x cannot equal, and it can equal 6, negative 3, and plus or minus 1. So we could say plus or minus 1, 6, or negative 3. Any of these numbers will make the denominator 0 in any place. So 6 minus 6 is 0, negative 3 plus 3 is 0, negative 1 plus 1, or 1 minus 1 is 0. So x cannot equal plus or minus 1, 6, or negative 3. So those are restrictions on the domain. And sometimes we just assume that that's going to be the case because if we see these, we know we can't have 0 in the denominator, so that must be the situation. Okay? So that's a pretty good example, I think, of multiplying rational expressions.